Okay, so the following is our video in R about how to create tables as well as graphical and numerical summaries. So hopefully you've already looked at our previous videos that talk about how to read in the hot dogs dataset. If not, please do so because we're going to reference it multiple times. So let's take a quick look at it. So we'll do head of hot dogs. And we can see here that we've got type, sodium, and calories. And within type, we have three different types: beef, meat, and poultry. Now, let's say we want to determine how many of each hot dog type we have. Then we'll use the table command. So you'll type in table, and then hot dogs, and type. And so what I'll do is I'll take a look at all the entries here and count the number of unique ones. So the number of times we see beef, the number of times we see meat, and the number of times we see poultry. And so we can see here that we have 20, 17, and 17 respectively. Now, let's say we want to make this a bit more interesting. Let's classify a healthy hot dog as one having less than 150 calories. So, how do we do this? So, there are two ways we can do this. The first way is to actually save the variable and then use a table. The alternative way is to use a conditional statement. The first way we'll do is hot dogs, and let's create a variable called healthy. And this variable is defined by saying that a healthy hot dog is anyone where the calories is less than 150. And if we take a look at the head of hot dogs now, we can see that, okay, this calorie here is 186. Is it less than 150? False, so it's unhealthy. Whereas this one here, it is less than 150, so it is true in terms of being a healthy hot dog. Now, to create a table, what we can do now is do a table of hot dogs healthy. So this becomes our row by hot dogs and type. Hit enter, and we have it here. Now this is what we would call a contingency table, a n by m, or in this case 2 by 3 table that looks at the count of the number of times a particular condition is met. In this case here, we have 11 beef hot dogs that are unhealthy, whereas we have 9 beef hot dogs that are healthy. So that's how we can create a contingency table. The alternative method is to use the conditional statement right inside the table command. So we'll do table, we'll call healthy, any hot dog that has a calorie count of less than 150. Again, this line here is going to be our row, and then the column is type. And this produces the exact same thing. Okay, so the next part we're going to talk about is a graphical summary. So let's create a bar plot. A bar plot is just the vertical lines that basically shows a graphical summary of a table, or at the count of the table. So let's say we did a bar plot and of our basic table of the count for the type of hot dogs. So this is hot dogs and type. If we hit enter, there we go. We've got beef, meat, and poultry, a nice graphical summary to compare the table. Now, to make things more interesting, let's say we want to do a bar plot or bar graph of the contingency table. So it will produce the exact same graph, but for each bar it will split it in half, it will split it based on the number that follow the condition of, in this example, healthy or unhealthy. So to do that, we literally would plot our contingency table. So I'm just going to save it since I know I'm going to use it a few more times. And then if I just did bar plot of cont, then what we get here is the same type of graph, but as we can see from beef and meat, it's split based on the number of hot dogs that are healthy versus unhealthy, where healthy is the light gray and unhealthy is the dark gray. Now, obviously, unless you know the data set, it's going to be hard to be able to tell which is which. So we can do the exact same command and then add in a legend. So we type in legend.text is equal to unhealthy and then healthy. Now keep in mind that they have to be within quotes and have a comma separating them. Now the reason we use unhealthy first and then healthy second is because of our table. As we can see here, we have healthy, false, true. The reason it's ordered by false and true is because when false is converted into a numerical value, it's equal to 0. And when true is converted into a numerical value, it's converted to 1. And therefore, based on regular order, false being 0 and true being 1 has to follow this particular order of false then true. So then unhealthy has to be first, and then healthy is second. So if we hit enter here and take a look at our graph, you see the following of healthy being light and unhealthy being dark. Now please ignore the fact that this looks scrunched up in the video. On your screen it should look a lot better just because I'm using a 800 by 600 resolution. Everything gets a little messy or ugly looking. Okay, so the next graphical summary we're going to talk about is the histogram. And the histogram basically shows you the distribution of the data. And it's pretty straightforward. We'll type in hist and then simply the value we want to create a histogram of. So we're going to use hot dogs calories again. And if you hit enter, you'll see the frequency of the value that comes up. And so as you can see here, the majority of values are occurring at greater than 100. Now this becomes very important later on down the road when we talk about normal data. Now when you have data that's normally distributed, this histogram is supposed to look like a bell curve shape, so nice and even. I won't talk about this here, but we will get into this later on. Now the third graph we're going to talk about is the box plot, which is very important. So the box plot tells you a lot of information about the spread of the data. So it gives you some of the same type of things as histogram, but also it gives you the first, second, and third quartiles. So we will type in box plot, and in the variable, again, it being calories. And if you hit enter, it looks like the following. So now you can see right here, this line here and this line here is our first and third. This line here is our second, being our median, and these lines here, these represent the whiskers, and so they're sort of like an indicator of the full spread of the data. So it's actually 1.5 times the IQR. This becomes important because it helps us to identify potential outliers. Now, with respect to the box plot, we can do this for calories, but as we already know, we have beef, meat, and poultry hot dogs. So if we wanted to take, for example, the box plot for each type of hot dogs, we can do that as well. To do this, we type in box plot, again, hot dogs, calories, and then if we add in this symbol here, the tilde symbol, this symbol here tells R that the next value here, which is hot dogs type, is going to be a grouping factor. So what happens is it's going to take box plot for calories, but do one for each different type there is. Now if you hit enter, you get the following graph. And now we can see here the spreads for beef, meat, and poultry. And there's obviously a difference between poultry versus meat and beef. Now there are a few other methods to do this, as well as plotting each one of these individually. The problem with that is the scale may be different. So you can ignore this part here, but it's just to give you an example of something here. So mf row is equal to Okay, so what I did is I just plotted the three different types on the same image. And the problem with this, as you can see here, is that now they look very similar, but if you look at the y-axis, the scales are very different. In the last one from poultry, I go from 60 to 120, whereas for the other two, I go from 120 to 180. And so this is why doing it the first method I showed you, by using the tilde symbol here, is much more important, because as we can see here, it puts them all on the same scale, or the more correct scale. So now you can see here that poultry is definitely very different from the beef or meat ones. And so using that symbol there, the tilde, is very important when using boxplot. Please note that for a histogram, it does not work. Okay, and the last part we're going to talk about is numerical summaries. So again, they're pretty straightforward. If you want to determine the mean of all the calories, you simply type in mean, hot dogs, and then the variable. If I want the median, it's simply median. If you want the standard deviation, it's SD. And if you want the variance, it's just var. Now, if you want to calculate the interquartile range, there is a function called IQR, but you'd have to load a library to do that. Alternatively, we can calculate it ourselves. And so you can type in quantile of hot dogs and calories. And the IQR is the 75th percentile minus the 25th percentile. Now notice that the 75th is in the fourth value here, and that the 25th is in the second value here. So if we type in the following, the fourth one minus the quantile of hot dogs, calories, the second value, you get 65, which is our IQR. Now alternatively, you could easily type in just summary of hot dogs, calories, and it'll actually give you the majority of the information we need, except for the standard deviation or variance. But we still get our min, our max, the first and third quartile, the second quartile, which is our median, and the mean. Now, the last thing I want to talk about goes back to what we did with boxplot. Let's say we want to take a look at the mean instead of the mean of all the hot dogs, or sorry, the mean calories of all the hot dogs. Let's say you want to take a look at the mean calories of each type of hot dog. So then we could do mean of hot dogs, calories, where the type of hot dogs is equal to beef, or you could use a command called tapply. And similar to the tilde symbol in boxplot, what we can do is tapply of hot dogs calories and apply it to type and the function. So what this does is it takes hot dogs and applies the function mean based on the grouping variable type. So if you hit enter now, you can see here, let's see, previously I had the average calorie count for beef hot dog being 156.85. So tapply does the exact same thing at 156.85, but now I have meat and poultry. And we can easily do this for our standard deviation by switching mean out with ST, as well as even the summary counts. And so this is one nice way to determine descriptive statistics for a variable, in this case here calories, based on a group identifier, in this case here being type. And so now we've covered our basic introduction to tables